Plumber, a company which makes a Java agent which detects your performance issues. And basically we spent a lot of time digging through the internals of the JVM, and I hope we could use that experience to answer your questions.
Thanks. Hi. Hello. My name's Richard, and you should definitely speak in English if you want me to understand your your question. I'm a freelance software developer and technical trainer, and seem to work on various miscellaneous projects that always somehow end up requiring some deep dive technical knowledge, be it on JVM internals, hardware mechanics, or what have you.
So my name is Volker Simonis. I'm working for SAP. SAP is a huge company which does a lot of things, but I'm in a small group which does the SAP JVM. So it's a Java virtual machine based on the hotspot from Sun and now Oracle. What we have done is we've ported the hotspot to many new architectures like PowerPC, Itanium, PRISC, System Z, and other operating systems like HPOX, AIX, iSeries. We are dealing with the SAP JVM since about 10 years. We have added a lot of supportability features and profiling, debugging stuff. We are also involved with the OpenJDK since towards 3 years now. We've donated the PowerPC AIX port to OpenJDK. So yeah, I would be happy to hear some hotspot questions from you.
Hi, I'm Attila. I work for Oracle, which is probably even a bigger company than SAP is. But I also work in a somewhat smaller group. I'm part of the Java Lang Tools team, which is tasked with Java tooling, Java C compiler, etc., etc. I specifically work on the Nashorn JavaScript runtime. In my past life, I did other things as well. I spent 2 years working for Twitter, where I was mostly kept in a locked room and forced to performance tune various JVMs. So you can probably ask me about that as well.
And my name is Nikita. I'm from Plumber as well. Well, essentially I am Gleb's manager and try to solve problems that Gleb creates for us. So we have a panel, so we will be silent until you ask anything or something. So if you don't ask anything, we will be silent. I will go away. So ask your questions.
All right, question for the audience. Why did you come to this panel?
Sorry, was there a guy at the back? You got a question? No? I volunteered.
Yeah, it's his job to be here.
Yeah, you volunteered, so you're forced to be here. Okay. All right, so that doesn't count.
Okay, so how about I kick off with a question? So one of the things which I've been kind of spotting or hitting a little bit more recently when being involved in some more various arbitrary, very latency sensitive projects is the extent to which safe points are a huge bane in terms of developers' life. So I have one project at the moment where the primary driver of latency increases is safe points which are generated with the VM no operation tag. So that's a safe point that's just being put in there by the compiler just to force a safe point to happen at some point in time. Interestingly enough, some JVMs try and avoid the whole concept of a safe point. So Azul do this where they have a safe point that's on a kind of thread local basis rather than bring the whole VM to a stop. So open question to the panel, have safe points outrun their lifetime? Is it worth investing in alternative mechanisms in JVMs to reduce safe point related problems or move to thread local approaches to stopping and halting a VM? What do you think?
I don't know exactly, but we have experimented with this. We call them thread local safe point as well, and it worked a little bit, but it made a lot of things also more complicated, and I think currently it's switched off by default in our VM again. So I think it depends a lot on the use case. So from our experience, I mean, usually we have enterprise customers. Of course, they care about latency, but not that much. I mean, the CPUs are so fast today. So if from time to time they have like a hiccup of several seconds, which is a lot for some people, I mean, they usually don't care because the people who are using this enterprise applications, they are sitting for their browser and they are used to few seconds pauses anyway. So of course they also have restrictions on how pause time, but for us it's currently not so important problem that we are investigating in this area. So.
I admittedly know very little about safe points, and I intended to stay this way. Yeah, I do speak with folks. I remember speaking with some people from Azure recently. Yes, they are making efforts to eliminate them. As far as I'm aware, safe points as such are nowhere to be found in the JVM specification. Is that correct? So
I believe there's no requirement that you have one.
yes, exactly. So this means that you could have a specification compliant JVM without safe points. From this point of view, they are a implementation artifact, which obviously has its as most design, it is a trade-off between something and something else. And now, if the drawbacks seem to be outweighing the benefits these days, and fortunately, seems like the implementers of JVM have reached a technological level where they are actually thinking about eliminating as many of them as they can. I mean, it's a spectrum, right? You don't need to either have them or not have them. You can have less of them. Yeah, I would be pretty happy if this became something that we didn't have to talk about at all in the future.
There's also another viewpoint for this problem. So, for example, we have our own profiler, and the problem with profiling Java applications is that you usually only profile them at save points. So when you eliminate a lot of save points, you get a very fast code, but it's very hard to profile it because maybe you don't see inline functions if there are no save points in between. And so what we are doing is that we can insert more save points. We call them profiling save points. So they are very lightweight save points. The total overhead of Java application is like 2 or 3% only. But we just randomly insert every, I don't know, few machine instructions save point, and usually they are quite cheap. I mean, if it's just a read from a memory page, if it's not poisoned, then just a read. But when you do profiling, you get much more accurate profiles. So this is also something that may be worth doing. So it's always a trade-off. What do you want?
Yeah, I mean, it's an interesting specific point you bring up about the fact that a lot of sampling profilers do profiling at save points. It's worth noting there are some alternative approaches. I've got some open source code on GitHub, which has a profiler which is using the async get call trace API, which is a non-standardized, non-official API that exists there, and is also used by the Oracle Solaris Studio profiler. So that gives you sampling profiles which don't have the save point bias. And also Mission Control is another project that has a profiler built in which doesn't have save point sampling bias. In all cases, they're under the hood at some level. They're relying on your operating system's signal handling mechanism to interrupt the threads on a basis, which means you don't have the same biases around save points.
Yeah, but the problem with these approaches is that it's hard to get valid stack traces at arbitrary points. So it's no problem to interrupt the VM at the arbitrary point. You can use performance counters, all kind of stuff.
Yeah.
But if you're not at a save point, you cannot safely walk the stack, and that's the problem. And on some architectures like Solaris Spark, it's easier because you have the framed registers. so you can always walk the stack. But on other architectures like Intel, it's more hard. Recently there has been a change in the hotspot which introduced the frame pointer again. So in JIT code until now the frame pointer is used as a general purpose register. So now they, if I don't mistake, they have there's a new flag which says that to use the frame pointer register as a frame pointer. So this will help to get more accurate stack traces at arbitrary points again, at the cost of one less register for register allocation. So
let me sidetrack a little with a question to the audience. Raise your hand if you actually know what the safe point is, just in case. Aha. So it appears to have a problem here.
Yeah.
So probably we should explain what the safe point is. So basically some operations that the JVM does, it requires all the application threads to be stopped. For instance, stop the world garbage collection, you need the threads to not be modifying your heap if you want to do a garbage collection. So to do that, the JVM stops all the threads, and such an event, such a point in the life cycle of the thread when it can safely be stopped is called a safe point, which is the name. So what we have been discussing is the how the implementation of the safe points, different approaches to it. So the classical one is to just, for the compiler to insert so-called safe point polls to your generated code. So every once in a while, your code checks and asks the JVM, should I stop? Should I stop now? Etc. many times. So for a demonstration, I have just recently gotten several examples of safe points. So what you see on the screen is the most common type of safe point, basically full garbage collection, which is a stop the world, or just any stop the world garbage collection. So if you run this one, you will see a lot of safe points, which is added by this magical flag. It says GC here, but in fact it displays all the safe points, not just the GC related. So if we run this, hold on. I forgot the keys. Hold on a sec, please.
Sure.
So as we see, we have two types of messages. One of them is something that you're probably very familiar with, the full GC and blah, 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 right? But the second one is the time for which the application threads were stopped. And it is basically reporting every possible safe point. In this situation, we see that all of the stop times when the application was stopped, there was a garbage collection. But there are also other cases in which safe points happen. One of the most common ones, I guess, is the biased lock. Basically, does everyone know what the biased lock is? Does someone else want to explain it so that it's not just me talking?
Yeah, shut up. You talk for leading eye.
All right. So basically, this is a kind of an optimization. The JVM, the creators of the JVM are pretty clever guys. So someone has once observed that it is quite often that you create a lock, or you synchronize whatever, and it is actually always acquired by just one thread. And you can avoid all the expensive synchronization operations, blah, 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 by being biased towards the thread which first took the lock. And then for that thread, it's practically free to acquire it again. But for another thread, you have to do an expensive operation of bias revocation and stuff like that. And by default, it's on, by the way. So here's a simple example. So we have a synchronized method, which is called content, which just waits and does nothing. And we have a lot of threads which all try to execute that method. So they're going to content. And if we run this one with the same parameters as we ran it the previous one, hold on. Wow. What we are going to see is this one. Application threads are stopped a lot of times, but there is no GC pause, so there must be some other reason for it here. And basically it's the save point required by the biased logs. Another common scenario is de-optimization, when the JIT compiler does some speculative optimization and decides, for instance, that there is just one implementation of some interface and inlines it, right, the calls to its methods right away. And then it de-optimizes it when it finds another interface, and that's also a save point. And there are many of them. So this is what we have been discussing.
So the reason why a lot of profilers, as we're mentioning, end up having a save point requirement is because they want to have a look at what each of your threads is doing. So they require a save point to make sure the thread's actually stopped, so they can walk the stack and read out and see what actual methods are there, which is the kind of standard profiling API that you'll get if you use something like Visual VM or JProfiler or something like that. We probably talked quite a bit about save points at this point. Does anyone from the audience have a question or anything? No? Okay.
And let's go on with save points. So there's pretty a lot of stuff going on. So a save point is not just the possibility to stop, but the VM has to know a lot of things at a save point. So it must know all the values which are live at that save point. So for example, it must know which register hold pointers into the heap. So it can do garbage collection, or it can de-optimize things and stuff like that. So if you ever run the VM with print disassembly or print opto assembly options to see the disassembly generated by the hotspot VM, which I would recommend if you have some spare time, you will notice that at the end of the disassembly, which is just machine code, you get a lot of stuff like PC descriptors and scope descriptors and OOP maps, and this is all stuff which this is information related to special PCs where a save point can happen. And for every of these addresses in the method, the VM has to know, okay, when the VM stopped at this PC, then I know that in register RA and R10 and I don't know, RB, there are pointers into the heap, and in other registers there is nothing important, and this register holds this value and all this kind of stuff, so that it can de-optimize the method, for example, and set up an interpreter frame, or to do the garbage collection, or all kind of other stuff. So there's complicated machinery behind save points. I have a question to the audience. Who is using, which version of Java are you using? So who is using Java 8? So 7, 6,
Why?
5.
Why do we still use Java 6?
Because of customer requirements. It's clear. Because they get money for it. So older than 6, 5, 4? No way. So which platforms are you running on? Like Windows, Linux, other than Windows and Linux and Mac? Okay. Are you all using the Oracle JVM or other VMs like IBM J9 or SAP JVM, OpenJDK, yeah, from Red Hat? It's all Oracle users. One question.
That's a big mystery for me still. It's a big mystery for me why people still use Java 6. Why we still use software that is dead already for some years? That's all necrophilia. Why?
So I think having interacted with clients and customers in the past, a lot of people are in a situation where the people who are writing the software aren't in control of deployment. So maybe they're shipping their software to a third party and they can't rely on that third party to have upgraded beyond 6. and in some cases they're shipping their software to or deploying it on some internal system, and their ops team is in charge of upgrading things. I've heard in the past scenarios where some large company has a support contract for their JVM that's tied to a version of their operating system. So if they wanted to move from 6 to 7, they would have to move the support contract from their OS from Red Hat Enterprise 3 to Enterprise 4 or something. So it really involves them moving an entire firm with potentially a lot of legacy systems to a completely different OS change, and that's a very high risk move for them. Oh, I agree, it's silly, but I'm just saying some of the reasons which I've heard for using legacy Java versions.
And it's not true that Java 6 is not supported anymore. So for example, we are still supporting Java 4 for the next 10 years or so. So and other big companies do as well. So Oracle also offers support. You cannot get it for free.
Yeah,
but,
so you have money to pay for the commercial support of old version of JVM, but you don't have money to upgrade your information system.
That's different. That's different money. So the clients, the clients build a system, and it's running perfect. And they say, we want to run the system the next 20 years. They just get a support contract from us. That's not too expensive for them, and they don't have to change their running system for 20 years. That's very convenient for them. So.
When you migrate a system, there's always involved risk. You don't know if it works, and paying money is safe.
Well, more accurately, paying money puts a bound on the risk to the amount of money that you've spent on keeping things the same. Whereas there's unbounded risk, which, even though in reality it might be cheaper, can often seem more expensive because it's unbounded, right? So.
Yeah, really. For me, being a more or less tool vendor, the requirement to support the older JVM version is always a pain, and so maybe one of the reasons why we still have sometimes bad tools is exactly because, well, we don't have the manpower to both support all the JVM and to move fast forward. So please, developers, kick your bosses as well to upgrade your JVM versions.
It's a pain for us as well.
So hard you lose your job. That's not a recommendation of the panel. We can't be held responsible for the consequences of you kicking your boss. But do it.
Yeah, it's actually still hard for us to support the old systems because, as you say, we do support Java 1.4, but we don't have support for the operating system it's running on. We don't have support for the compilers. It's even sometimes we even don't get the hardware anymore. For example, I told you we still support PA RISC, but you cannot buy PA RISC machines since years. So it's really hard to keep some machines with the old operating system, with the old compilers in your server room somewhere in the server and keep them running. And yeah, that's why it's so expensive to get support for old versions.
Okay, so I get. Is anyone in the audience got a question? Ah, fantastic! Just shout it out. So the question is, what are the JVM changes incoming in Java 9, and what's good, what's bad? What do people think? I think, publicly stated, probably the biggest change at the platform level is Jigsaw. I don't know whether that counts as a JVM change. I guess Jigsaw has a lot of interest by some people. Some people kind of talk about it a lot. I'm not sure myself I quite hit the kind of exact sweet spot for use cases or for users for Jigsaw, but I'm sure that maybe for some people who want to ship smaller, more cut down JDKs or want to ship more cut down JVMs, then there's possibly some use cases. I don't know. What do you guys think?
I'm not sure. I think for us, as we are doing a server VM, it's not that much of a feature we will use, because anyway we always ship the complete JDK. We have now a Java runtime environment because we had some requests from installers, people doing installers, but in general we always had a JDK because size didn't matter. So, but nevertheless, I think it will be a big change with Jigsaw, especially for tool vendors. So maybe they can say something.
All right. We'll give a chance to the tool vendor a little bit later on. Well, Java 9 has several things on the JVM level. I think finally some of the GC combinations are deprecated and or removed. That cleans up the code base a little bit. If you ever look into the hotspot code base, the need to support frankly ridiculous cross product of various young gen, old gen GCs becomes unmaintainable after a while. So that's definitely one of the welcome changes. Another interesting thing that happens with Java 9 is, and I think it is probably related to the module system, is that the class path as we know it is changing. So the extension directory is pretty much going away. So JRE libext no longer really works. Boot class path can be specified currently, but I believe that too will also go away. So you probably won't be able to completely override the boot class path anymore. And if you look into the deployments, then you no longer have an RT jar, but rather you have something J image, which is actually its own little file system in there. Basically, there is parts of the JDK, parts of the library that actually is an API for working with J images. So J images sort of the new jar, if you will. This has all kinds of consequences for people trying to, override things in the boot class path, deploy things as extensions, just override things. My personal experience is when I'm working with Nashorn, right, and we Nashorn is shipped as part of the JDK. Is my usual mode of development used to be that I would just override the ext directory to point to wherever I build Nashorn, and with Java 9 I can't do that anymore. Now I have to prepend it to the boot class path, but soon I will probably not be able to do that either. So even just in the house, just developing, is moving towards not really being able to work on Nashorn in isolation, but just basically having to do having to work within a full OpenJDK project all the time, which obviously is less lean than if I can just build Nashorn and substitute it into an otherwise built JDK and just test my stuff. I guess just have to live with that. Modularization wise, I am, embarrassingly enough, I'm actually not terribly versed into how does the module system work. I know that it has some otherwise profound implications on reflection and whatnot. So again, just coming from my own background from Nashorn, we have a colleague of mine is just now trying to figure out how to have dynamically generated classes like what Nashorn builds from JavaScript source, actually be able to see classes in modules so that they somehow declare that dependency. So you might have that particular class dynamically trying to instantiate an instance of something that lives in a different module, and now suddenly it needs to have a declared dependency on that, and figuring this out from a dynamic language, well, not easy. So yeah, modules will create a lot of so I think a lot of things that sort of accidentally did work previously will now, because of introduced explicit boundaries, will probably not work so well anymore. So in terms of that, at least Java 9 will probably be a slightly painful to transition to than any previous version was. But yeah, that's all I can think of really. The module system, the boot class paths going away, X class paths going away, and various GC combinations being deprecated. So
I have just previewed the list of JEPs targeted to JDK 9. Have found my two favorites. One is like a tool vendor who has to support the previous Java versions. We have a possibility for Java to tell for which Java version I would like to compile my classes. So right now you can specify the target platform, Java 6 or 7, but you cannot enforce which API you use. So you can use Java 8 only APIs in your code and still compile bytecode for Java 6, and it will fail on runtime. So we have compiled for older platform version support. That's nice. And another one is unified JVM logging, because well, the logging of different JVM information right now is totally ad hoc, and as a tool vendor, I have more or less no control about that. So, for example, I can programmatically turn on GC logging in runtime in already running JVM, but I have no way to tell to what file those GC logs should go. They always will go to console standard output. So more or less useless for me. So unified JVM logging, when we have the standard logging mechanism for all JVM subsystems, that would be very good, because then we can hack into them and piggyback them and get all the information we would like from that. That's my two favorites.
Another thing about tool vendors and upgrading the JDK, the thing is we have just recently found that we have more Java 8 users than Java 6 users, and still most of our customers use Java 7. So to us, actually, Java 9 is a very far away perspective, because even after it's out, people are going to take a lot of time to actually roll it out to production. So, yep. Another thing, I'm not sure it is actually planned for Java 9, maybe it's for later, but the overhaul of all the unsafe business is something that's really exciting. So for now, does anyone know if it's in Java 9 or later?
It's not exciting, it's scary. Scary, because well, you have unsafe. You have your tools using unsafe all over the place, and then well, they have plans to hide unsafe, to throw unsafe away, and we can only hope that all the useful APIs will be still available.
So quick question to the audience: who's used SunMISC unsafe, or who's familiar with SunMISC unsafe as a class? A couple of people. Okay, well, I got that. So the basic premise of the Jigsaw module system is that you're only able to expose part of the public API from your module. So any of the existing classes that are inside the JDK or the JRE, which aren't part of the public API, you won't be able to touch. Now, some of these classes are things which people have historically used as useful functionality, and SunMISC unsafe is probably the one class that loads of people accidentally touch. So if you're using any kind of mocking framework in your day-to-day code, your mocking framework is probably using SunMISC unsafe under the hood, because it lets you do things like instantiate a new object of a given type without calling its constructor. If you are using most of the JSON serialization libraries, I think both JSON and Jackson use SunMISC unsafe under the hood, so if you use either of those, you're touching it. I think Spring and Hibernate both also use unsafe at some point in time, just because there are all these miscellaneous features which unsafe has It also allows you to do a lot of kind of arbitrary peek and poke reading and writing of data at arbitrary memory locations. And it's also got a bunch of concurrency primitives as well. So if you ever see the atomic long, atomic int, any of those classes in the public API, what that class is really doing is delegating to a method call on sunmisc unsafe, and your JVM under the hood will see, right, this method's going to be called, and I'm going to replace that method with some useful set of machine code, which is going to actually implement this method. So things like atomic int, atomic long don't really do much at the class level. So, there we go. There's a good example. So they've got an unsafe object, and if you just pop down to say lazy set, there we go. So you'll see here the public get and set method is just delegating to a method call on this unsafe class. Now that's okay for things like atomic int and atomic long, because they'll be in the same module as this unsafe, so they'll be able to use the private API. But anyone on the outside, like existing mocking frameworks, Hibernate, Spring, Jackson, JEECon, there's going to be a difficult library transition phase. Does anyone else have anything to add on that front?
The reason why we started this is that in some upcoming Java version, I'm not sure if it's 9, it probably isn't, but there is a plan to, instead of this unsafe business, which is unsafe, basically, there is a plan to introduce a lot of different APIs which are not private internal stuff, but they are actually public things which you can use for your whatever purposes. And this is something really exciting for tool vendors as well, I guess.
Well, yeah, one of the things that currently lives in unsafe sort of by default, because I guess they figured let's just put it there, is define class, which unsafe define class is used to define anonymous classes that really don't have a name, don't have an honest to goodness own associated class loader, and can at runtime you can basically at definition time you can externally populate their constant pool, so you can have like a template class that you can specify your template class, and you can specify constant pool entries additionally, and then you get a class for that. So this is a lightweight class definition facility, which for dynamically generated code actually makes sense a lot. Java Lang Invoke actually uses it to generate various method combinators on the fly, and that happens to be a functionality that would actually be pretty safe to use, because you always need to pass another class loader, another class that is actually doing the definition, so it inherits the security context, the code source, and so on from the invoking class. That is one of those things that could be a meaningful candidates for actually providing as a public API eventually. But of course, there is a bunch of other things in sunmisc unsafe that, well, you know, the class is fairly clearly labeled as unsafe. So, as speaking as employee of Oracle, I cannot really express any public sympathy for anyone depending on unsafe. So.
Specifically, what unsafe lets you do that people refer to it as unsafe because of is it lets you read and write values at arbitrary memory locations. So it's got, for example, a method called putlong that takes an address that's literally pointed to somewhere in memory and a long value. So if you do, say, putlong 00, you can segfault the JVM. That's probably actually the quickest way of segfaulting the JVM. But you know, that's why people refer to it as unsafe, because it is possible to cause a segfault, some kind of crash, by using it that way.
On the screen is basically one of the examples of what is done with unsafe. So probably you have seen the new long getter and stuff like this in the Java 8, and it's also implemented using unsafe. And this is exactly some of the things that we do, just put an integer to an arbitrary place. And okay, we shouldn't really be looking at this because it's inherently unsafe.
Does anyone else have a question? Ah, fantastic. What's your question, sir?
The question is about the G1 garbage collector being set as default in Java 9. But is it a question if it is going to happen or why or?
There is currently a discussion going on, I think, on the GC mailing list in the OpenJDK, if this should be done or not. I think it's not, there is a plan to do so, but some people think it's good, some think it's bad, so I'm not sure. I think Oracle definitely wants to make it the default garbage collector. If Oracle wants, it will probably happen, but yeah. Other vendors maybe will go another way. Other vendors even don't have the G1, so you at any time you can still use another garbage collector by specifying the corresponding options in the command line, except of course the one which will be eliminated in Java 9. So I think that's not so much of a deal. I mean, I would say any serious application anyway specifies and tunes its GC options, so that would be just this would not affect any application which specifies the GC it uses and tunes its options. So it's just people just doing Java Hello World, and I think it's no different if you're using G1 or any other collector.
I think one thing it does bring up is perhaps a good opportunity if you do have reliable performance tests or load tests in your system, to try running your system with different GC combinations. And if you do find some kind of performance regression, being able to explain that publicly, I guess is always useful, because I suspect people will be looking for more useful evidence as to whether G1 is performing or not performing appropriately. I don't know about you guys, so I've done some performance testing for applications on G1, but with earlier versions of G1 where it really was not coming up to par on a lot of cases. I hear that newer updates are much improved on a number of performance fronts, but I think a lot of people are still not very happy with G1 on a lot of respects. I don't know if you guys have more data on that.
Well, my knowledge is completely outdated in this regard, because last time I tried unsuccessfully to tune G1 was in 2011, so I would hope that it came a long way since then. But I don't know, do you have more recent experience?
Well, 2 years ago I would say that, well, G1 is totally crap. 1 year ago I would say that, well, I would like to hear somebody use that successfully. This year we have heard a couple of people saying we are happy with G1. So it is improving, seems to be, but, well, is it ready to be the prime, the default GC? Well, like Richard or Volker said that if you're not satisfied with default, you can always change them. So, well, the choice of community of Oracle of default GC, well, it doesn't really matter, because, well, you choose the one which suits you, your particular environment or your particular application. So that's not a big deal.
So for us the main concern is even not performance but stability. So we still find a lot of bugs, real bugs in G1, and if you see at the GC mailing list, you will see that there are still happen a lot of changes and bug fixes in G1. So I mean, you can think what you can make your own you can think what you want about this, but I think it's you can try it, but it's probably not as major as the other collectors. That's a matter of fact. But on the other hand, I think it's good to make the default collector to find even more problems and to fix them faster, because otherwise you will never get to an end. Well, I mean, Oracle has no chance to test all the scenarios in the world, so I mean, it's simply impossible. So yes, they can use the but that's what they are doing when they are using as the default collector. I mean, they got a big community.
Well, to be honest, you can already enable G1 in Java 8 if you want to, and as for the latest releases, there's always early access releases for Java 9, so it's like, yeah, of course, testing by community, but on the other hand, after a while you have a system that's so complex that you just cannot have a test matrix that covers everything in-house. Yes, we do rely on people already using Java, trying out a new release of Java before it gets final. Still, obviously, yeah, it's a good question how effective the strategy is, because sometimes, obviously, I have also encountered situations where we were pushing out the early access releases and didn't get any bugs reported, and then when we finalized the release and pushed it out, then people suddenly, hey, here's this bug. Yeah, of course. Well, since obviously in production you will only adopt something after it is finalized and published, and even in the community, not everybody has the resources to just have a completely separate set of servers that they will just be running with the new releases. But still, it's a good idea. In the long run, I'm not saying you have any kind of obligation to help us make Java better, but if you can, that's great. So, because yeah, obviously it's absolutely impossible for Oracle or any other OpenJDK participant, for that matter, to just have a full test matrix for anything that can ever happen in a JVM. So that's obviously complexity is too high for that. If it wasn't, it would be a trivial product, so we wouldn't even be talking about it.
Yeah, so I think we've reached time now. It's 3:15. That's right. Okay. And we've answered 2 questions and discussed the rest of the time. So I hope you guys enjoyed this session. Thank you very much for coming.